least squares line for the relationship between the number of absences for a student and the student's final grade is given as y hat is equal to negative 2.67x plus 96.78. Find the 95% confidence interval for an average student's final grade given that the student was absent 7 times. And they give us the summary information for the problem. So we're told here that we want to find the 95% confidence interval. So we know we're dealing with a confidence interval. But here's a very important phrase here, for an average student's final grade. So an average student's, not a specific student's final grade. That's going to change what formula we need to use. And then it goes on to talk about the summary values that are given here below. Okay, so let's talk about the formula that we're going to work on for this problem. To do that, I really think we'll work it through as we go by doing the 4 steps we normally do for a confidence interval to keep that connection. So our first step is always to write down the data. Now we have the data basically summarized here, so I'm not just going to rewrite all of that, but I will say that alpha here is 0.05, and our model turns out to be y hat is equal to minus 2.67x, and I'll leave a space for x. I'll show you what we're going to do with that in a minute. And we have 96.78. So in step 1, we normally would record all the data, which is already done for us. We would identify alpha, and then in this case, we have a new step 1 because this is a special confidence interval. We're going to first need to get the average value that we estimate for the scenario where a student has 7 absences. So remember that we're talking about a student who's been absent 7 times, and x represents the number of absences for a given student, and then y is supposed to be the student's expected final grade given that scenario. So I'm going to put in the 7, and what this is going to give us is a point estimate for the person's average final grade. Now, of course, that's an estimate of the final grade, but it's a point estimate. We're going to finish the 4 steps so that we eventually get an interval estimate of the student's average final grade, right? This is a point estimate of the average final grade. Point estimate just means it's a single value. We're eventually going to want to construct an interval estimate of it, and that's what this is going to give us by the end of the problem. All right, so let's first plug that 7 in like we just did, see what it gives us for this specific person's scenario, and see what the average grade we expect for somebody who has 7 absences. So minus 2.67 times 7 plus 96.78. Okay, so students who have 7 absences on average, according to this, are estimated to have a mean of 78.09 as their final average in the course. Okay, so that's our y hat. That's the first thing we needed, and that's what we did in step 1. Now our step 2 is going to be to get a table value. We're going to need to get the t alpha divided by 2 value with degrees of freedom n minus 2. So that's going to be, in our case, t alpha divided by 2. In our case, alpha is 5%, right? So half of that is 0.025. And then degrees of freedom here, well, our n is 6. So if we take away 2 from that, we're going to have 4. All right, so let's see what that gives us for our critical t value. So let's go to our table and look it up. Okay, so we're looking for 0.025 with 4 degrees of freedom. We get the value 2.776. Okay, so we found our critical value to be 2.776. 2.776. All right, so now that we have that value, we're going to put it to use in our next step, which is the margin of error step. So the margin of error for this problem is a little more complicated than we usually see, but it's not, any more difficult in the sense that it's just a formula we have to fill in, right? So it's a longer formula, but it's still just a formula to fill in. So the formula involves our critical table value as always, right? So it's t alpha divided by 2. Actually, let's go ahead and write it in. We'll write the formula underneath here, and then we'll fill it in just so we know what we're actually are doing. So it's t alpha divided by 2, and then we're going to multiply that by s, which is going to be the standard deviation for the error term in our model. And we have 1 over n, right? Plus the parenthesis here, which is x sub p. That means the predicted x value, the predicting x value, the value we're plugging into the model, in other words, right? So the predictor minus the average x value, quantity squared, divided by the summa square for the x's. All right, that's our margin of error formula. So plugging that in now, we have our table value, which is 2.776. We have our s value given to us as 2.77, so that'll be 2.7755554, right? Times the square root of, now the square root is 1 over n, that's 1 over 6 for us, right? Plus the x predicted value, so the predicting x value, which is 7, minus the x bar value. They gave us that as 6.167, so 6.167. And then from there, we're going to square that and divide by the sum of squares for the x values, which they gave us as 108.8333, so on and so forth. Okay, let's plug that in then and see what that all works out to be. Okay, so we're going to have 2.776 times 2.775554 times the square root of, it'll be 1 divided by 6 plus, open parentheses, 7 minus 6.167, close parentheses, square, divided by 108.8333. Close up the parentheses, hit enter, and we get the answer 3.205. So 3.205 if you round it off, right? So 3.205 ... Okay, so that's our margin of error. That's our very important value for our interval, because we're going to use that as the thing that we add and subtract from our point estimator. So I'm going to store that in my calculator now as x, and this will be there without rounding it then for our next step, step 4. Okay. Now, in step 4, we do the fourth and final thing that we have to do to fill out all confidence intervals. We take the point estimator, which in our case comes from step 1. Now, normally, way back when we learned our very first confidence intervals, we had x bar as our point estimator. It used to be x bar minus e, x bar plus e. Well, now it's just y hat minus e, comma, y hat plus e. Okay, so for us, this is going to turn out to be 78.09 minus 3.205, and then 78.09 plus 3.205. And that'll give us our solution then. So let's see what that turns out to be. Okay, so we'll have 78.09 minus the x value that I stored in my calculator, 78.09 plus that value. And our interval becomes a nice 74.88 up to 81.30. That's just rounding it to 2 decimal places. Okay, so there is our interval, right? And the way we interpret this is very simple. We say that we're 95% confident. We are 95% confident that, and then just repeat the phrase here, that the true average student's final grade, so that the true average final grade for a student with 7 absences is between 74.88% and 81.30%. So again, it's important that we're saying their true average final grade, right? Not their specific final grade for a specific student with 7 absences. Right? That's another type of confidence interval which we'll learn later, called a prediction interval. In that case, we'll actually be trying to predict a particular student's average grade given their number of absences. But here we're talking about, on average, students who have 7 absences, their grade would be somewhere between these two. Their average grade would be somewhere between these two numbers, about 75 to 81%.